For today's lesson, we're going to represent graphs and tables. We're also going to identify and plot points in our coordinate plane. For question A, give the coordinates for A, B, C, D, and E. For question B, plot these points. Just a reminder, for H, this tells you to go left 3 and then stay. So H will end up on your x-axis. For question C, you're going to make a table of values. You were given the domain, and if you're given the domain, then you know that you must have a discrete graph. So figure out your values for -6, -4, -2, 0, and 2. Notice these were conveniently chosen because if you divide by 1/2, all of these numbers come out very nicely. Show your substitution. 1/2 times the quantity -6 plus 2. Follow the order of operations. -3 plus 2 is -1. So plot your points. Left 6 and then down 1. Left 6, down 1. When you're finished, make certain that you have only 1, 2, 3, 4, 5 points on your graph. The range are the y values that you're going to list. And is the graph discrete or continuous? If you only have 5 points, it is discrete. Here's a reminder. The origin is called 0, 0. And that is where your x and y axis intersect. A solution to an equation is an ordered pair xy that gives you a true statement. Now, the graph of the equation is a set of all the solutions possible. And a linear equation is an equation whose graph is a line. So we've had a couple different equations. Some made V's, some made U's, and some make lines. For example 1, we're going to tell whether 4 and -0.5 is a solution. To do that, we substitute. Replace x with 4, replace y with -0.5. Does that equal 5? So let's see here. Is 4 minus 1 equal to 5? That is false. So we know that 4 and -0.5 is not a solution to this linear equation. For example 2, tell whether 2 -1 is a solution. Substitute your 2 in for x and your -1 in for the y. And is that equal to -7? Follow the order of operations. Is -4 minus 3 equal to -7? And that is true. And because it's true, yes, you have a solution. 2 -1 is a solution. So we'd like to graph example 3. Notice for this one, y has not been isolated. So let's divide both sides by 2. We get x over 2 minus 3 over 2. So now that we have our y value isolated, we should pick out some x and y's for this function. Notice both of these have a denominator of 2. If I choose a couple of odd values, -3, -1, 1, and 3, it's going to work out nicely for us. Substitute -3 over 2 minus 3 over 2. That's -6 over 2 or -3. Substitute -1 in. I will get -1/2 minus 3/2, which gives you -4 over 2, or look at that, a lovely -2. Now, when you substitute 1 in, you will get a -1, and 3 will give you 0. Plot your points. Left 3, down 3. Left 1, down 2. Right 1, down 1, and 3 with 0. Now, you should be asking yourself, do I connect these dots? Yes. Now, the reason that we connect the dots is you got to pick the numbers or I got to pick the numbers. Therefore, every x value is possible. When I'm looking at example 4, once again, y has been isolated, so I can just go right ahead and pick out numbers for my graph. But look, we have a domain restriction. My x's are only allowed to go between -1 and 4. So you might pick out -1, 0, 4, a few numbers in between, that's fine. The opposite of -1 plus 3 is 4. 0 plus 3 is 3. Put in 4, I get -1. Plot my points. Left 1 up 4, 0 up 3, and then I'm going to have 4 down 1. Again, can I connect my dots? This is a continuous graph. The difference is I am not allowed to have any x values outside of -1 and 4, and I do not, so we're all set. I'm going to identify the range now. Remember how to do that. The range are the y values. So if I draw my box around my answer, just to help guide what I'm doing, the y values are trapped between -1 and 1, 2, 3, 4, 5. No, 4. So -1 is less than or equal to y is less than or equal to my 4. So we have our y values trapped between -1 and 4. So a linear equation is one that can be written in the form ax plus by equals c. Now you can recognize a line if your x is to the first exponent and y has a 1 as an exponent as well. When I look at example 5, I'm asked to graph x equals -1. Notice that's x to the first power. So that means I do have a line. This is a special one. Here's x, here's y. I usually pick my x values, but according to this, x has only one answer. But y could be anything I want. So maybe I pick out -2, 0, 2, whatever I feel like. I'm going to plot those points. Left 1, down 2, left 1, 0, left 1, 2. Is this a function? No, because -1 has many answers. Is it continuous? Yes. This is a vertical line. A vertical line comes in the form of x equals any number at all. So I'm going to write x equals a. So this is a vertical line. It's a special problem. You can still make a table, but it looks a little different. Aha. Now y to the first power. Again, this is a line. Draw my table. Here's x, here's y. Now, I can pick any x value away. Oh, that's not quite true. X's are greater than 1. So 1, 2, 3. That sounds good. But wait, all my y's are equal to 2. So plot my points. 1, 2. 2 with 2. 3 with 2. And all of my x's are bigger than 1. It is a continuous graph. It is also a horizontal graph. And a horizontal graph comes in the form of y equals some number. So we now have equations for horizontal and vertical lines. For example 7, I'm giving you a table for the number of hours worked with the corresponding pay in dollars. So if you work 1 hour, you get paid $7.50. Estimate where that is. 2 hours gives you $15. 3 hours is $22.50. 5 hours is $37.50. And 8 hours is going to give us $60. We need a new job. Does this graph represent a function? Does each x have one y? Yes, because each x has one y. Now, this one, should it be discrete or should it be continuous? So I think you can work fractions of an hour. So I'm going to connect those dots. And I also think that you could probably work 0 hours. So I might even extend my line in both directions. So for your lesson practice, you're to graph, now think about number 1, number of players, don't think you can have a fraction of players, so this one should be discrete once you're finished. And think about it again for number 2. You were given a very specific domain. That one's probably discrete. Follow the previous examples to find out if you have a solution. As you look at question number 5, notice the y has not been isolated. Maybe you should move the 2x to the other side of the equation. So that you have negative 2x minus 1. Isolate that y. I'll make it easier to graph. For number 6, you're riding your bicycle and you're told that the distance is 10t. You're going to ride for 3 hours. Graph this function and identify its domain and range. So if I go starting at 0, my distance is 0. If I go to 3 times 10 is 30. I'm definitely going to have fractions in the middle. So we have our graph if I've only traveled for 3 hours. Now your domain would be from 0 to 3 hours. So 0 is less than or equal to your t is less than or equal to 3. But your range, the miles, that's going to be 0 less than or equal to your d is less than or equal to, now what's the highest point? 30. And that would be for the miles. What's the greatest distance you can ride in 3 hours? So give these problems a try and have a great day.